The Argument Clinic. Controlled experiments. Consider this. Research in the US shows a strong association between burglary rates in some southern states and the consumption of ice cream. The more ice cream that was eaten, the higher the rates of burglary. What's going on here? Something in the ice cream? Perhaps sugar, or food colouring that was tipping would-be burglars into reckless acts? Or perhaps the burglars were just particularly fond of ice cream and liked to celebrate a successful crime spree with a double-scoop choc-dipped sugar cone, with sprinkles. There's a correlation here, but it's hardly likely that either one causes the other. It's far more likely that both are influenced by a third factor: high summer temperatures, driving up ice cream sales and leading to open windows and doors and unoccupied residences, the ideal conditions for burglary. Or so my burglar friends, of whom I obviously have none, tell me. As I hope you saw in an earlier film, it's a common mistake to assume that correlation automatically means cause. Researchers often want to compare different groups of people, younger and older, those with religious beliefs and those without, burglars and voiceover artists. Here's an example. The researchers looked at children in a disadvantaged area who had attended kindergarten. They were interested in how well these children got on when they progressed to infant school, and they noticed that those who had attended morning groups at the kindergarten tended to perform better than those who had attended in the afternoons. What was going on? Maybe very young children are more alert in the mornings and therefore get more from the activities. Perhaps the afternoon classes were more inattentive or lethargic because they just had lunch. It's possible the staff were more effective in the mornings and more tired in the afternoons. I know the feeling. I'm recording this at 4 p.m. and this is take 23. Start again. In fact, mornings are more popular with parents, particularly working parents, so these usually fill up first. In disadvantaged communities, afternoon places generally went to parents who hadn't got around to registering their children until late in the process, or relied on social workers booking places for them. So there did seem to be a real morning-afternoon effect, but seemed more likely to reflect differences in home backgrounds and environments than what was happening in the kindergarten. Even then, this was only the researchers' best guess. How might we find out for sure? Scientific research frequently starts with a testable question. This is called a hypothesis. We then need a method capable of addressing the question. Typically, this is a controlled experiment. We can test the effect of making deliberate changes to a variable, an item, factor or condition that we can control, thereby ruling out other accidental changes that might obscure the result. In experiments, we can test the effect of changes in independent variables, changes that we either control directly or whose occurrence we can predict, on specified other variables in the experiment called dependent variables that we are interested in and that our hypothesis suggests may change as a result. We measure any changes in the dependent variable as we observe, or induce changes in the independent variable. To be sure that we see changes only in the variable of interest to us, we need controls to rule out irrelevant influences or effects. The way to do this is to have two groups of more or less identical experimental subjects, such that, ideally, the only systematic difference between them is that with one group the independent variable is changed, and with the other one it isn't. Now, let's proceed with our example. The research question is, does being in a morning class really lead to better outcomes than in an afternoon class? To find out, we need two groups of children who are matched as closely as possible in terms of home background, distance travel to school, general health, and so on, so that there were no systematic differences in these respects between the two groups. Then we would randomly distribute each group into a morning class and an afternoon class. 2 groups, 2 classes, 4 classes in all. Then we evaluate the children's learning over the period of the experiment, say 4 weeks. Halfway through, we deliberately intervene in one of the groups. We swap the morning and afternoon classes in that group. But we do this only in the intervention group. In the control group, we don't. We just let things run on as before. If there is a real advantage to being in a morning class, then it should show up in changes in the general performance of the children in the intervention group. Those moving from morning to afternoon should show a decline in learning performance. Those moving from afternoon to morning should show an improvement. By contrast, there should be no such systematic changes apparent in the control group. By the way, if no advantages are revealed in the intervention group, it doesn't mean the experiment was a failure. We've learned the valuable lesson that the explanation for the phenomenon first observed must lie somewhere else. That's the nature of research. Finally, remember that it is one thing to show experimentally that an intervention works in tightly controlled circumstances, but quite another to argue that it would operate as effectively if it were scaled up to run in the population at large. I look stunning in this purple sequined outfit, but it wouldn't suit everyone. Controlled experiments are powerful ways to help us examine how one thing affects another, in both the natural and the social sciences. There's a particular challenge for social science research. Because we're dealing with human behaviour, we often have to make compromises while finding creative ways to stay as close as possible to our ideal experiment. Every compromise that we make has an effect on the strength of our causal claims. So, if someone presents you with a causal claim suggesting 100% certainty, you know with 100% certainty they cannot possibly be a Durham University graduate. Something to think about. How would you design an experiment to determine how effective these videos are? Asking for a friend. Absence of evidence is not evidence of absence. How can we design experiments to avoid this trap?